Hello, everyone. So this video is going to be over section 1.8. This video, I assume it's going to be a short video. But before I start the actual lecture, I just want to go over a few announcements. I have done the announcement about the exam on the last video as well. I'm just going to do it one more time. The exam one is next Thursday, which is September 10th. And this exam will be over section 1.1 to 1.8. So basically all the sections from, I think I started from 1.2, right? Sorry, yeah, it should be from 1.2. I didn't, it should be 1.2. Yeah. So basically all the section from section or chapter 1 and also section 2.1 and 2.2. And I'll also provide a review by, I don't know, by Thursday or Friday. All right. And the second one is the wave assigned homework. The wave assigned homework of section 1.6 and 1.7 is due this Saturday, as I have been sending you guys email about it as well, right? About the web assigned homework of 1.6 and 1.7, which is the due is on September 5, which is coming Saturday at 11:59 p.m. And also since I'm covering 1.8 and this 2.1, 2.2 for exam 1. So since the exam is on Thursday, so I'm gonna make the homework due for these sections a night before, all right, a day before, on September 9, which is on Wednesday at 11:59 p.m. All right, and this 2.1 and 2.2 homework will be just one homework. All right, so basically, even in the lecture, I will be just making one lecture for these two sections, and also you will see just one homework. All right, okay. And obviously, like as usual, if I assign any quiz in this video, well, since this is Tuesday lecture, right? Tuesday lecture. So any quiz that is assigned in this lecture is due the next day. That means it will be due on Wednesday, the next day, Wednesday at 11:59 p.m. Right? That's the normal schedule of the quiz, right? That's what I've been saying every time, or I've also mentioned in one of the video that, yeah, anything that is assigned on that particular, or any quiz that is assigned on that particular day, the due of that quiz is always due next day at 11:59 p.m. Right? Okay, now let's start this section. This is section 1.8, which is going to be about continuity. So basically, like I said before, this section is a very short section. I'll just quickly go over this. So first we will start with the definition, DEF, and so this is definition. This means definition. All right. So the first one, let's say the definition is a function f is continuous at number a if so a function is continuous at a certain number, a number a, where if I say x approaches to that number and a certain function, then we get f of a. Okay, so this should satisfy this. And also there is a condition where we have to say that, okay, this f of a is defined which means there shouldn't be any undefined thing. Like I said, if you work with the fraction, then you cannot divide any number, anything. Let's just say anything. Let's just say 2 over 0. Then this is undefined, right? So you shouldn't get anything like that here. And similarly, this limit on left hand side, the limit exists. Okay, which means the limit exists means this limit cannot be undefined, or you can even say is not equals to, let's say, either positive infinity or negative infinity, or undefined. Okay, so this should be the condition to say that, okay, a certain function is continuous. All right, now let's do an example to explain this. Okay, so the example we have here is, let's say f of x is given, and here we need to find, let's say f of x will be given, and find discontinuous point. Discontinuous point. Let's say f of x is x squared minus x minus 2 over x minus 2. All right, so this is given, and we need to find at what point this function is discontinuous. So, like I said, a function here, oops, here I say a function is continuous if f of a is defined. There is a number where the function will be defined. If the function is not defined, then we can say that at that point it is discontinuous. All right, so at what point we can say that this function is undefined? Because, okay, and whenever we are working with a fraction, like I said, you have to make sure that the denominator is not 0, right? Now, if I say, if x value from this, if I say f of 2, we can directly see that, right? Because if x is 2, then here on the denominator, well, on the numerator, you will get something, right? So 2 squared 4, minus 2 is 2, even on the denominator, but it doesn't matter whatever we have in the numerator, right? Let's just say start on the numerator. But in the denominator, we're getting 0, right? So it doesn't matter what we have in the numerator, and as long as you get 0 on the denominator, that means this function is undefined. Right, so that means when x is 2, it is undefined, right? So f is discontinuous at x is equals to 2. But is there any way we can make this continuous? Well, I mean, yeah, if you directly say this, yes, it is undefined, or there is basically whenever you say discontinuous, that means there is a hole in that function. Let's say, I'm just making a random picture of this, all right? Let's say if this is the graph of this function, then there is going to be, instead of saying this, let's just say, okay, let's say this is the graph of this function, then we're saying that at x is equals to, it's undefined, so there will be a hole at that point. So if this is on x-axis, if this is 2, then there is a hole at that point. All right, so all right, that's the idea. Now, how can we make this continuous, or how can we make this function continuous? All right, let me just write that on the next page. How to make f of x, that was given on the last page. How to make f of x continuous? Well, we can make f of x continuous by factoring the numerator, right? Because if I factor this numerator, then probably I can cancel something on the top and something on the bottom, or this whole thing on the bottom and something on the top, right? So let's find the factor of this x squared minus x minus 2. Let's find the factor of that. So I can find the factor of this. Well, there is a 2 here, so 2 times 1, that's 2. And it looks like I can only use 2 and 2, so using 2 and 2, I can say that, well, since there is negative x, so I can say negative 2 and x plus 1, right? So that's what we get from the numerator. So that means f of x is x minus 2, x plus 1. On the bottom, we have x minus 2. So that way I can cancel this x minus 2, x minus 2. So well, we have x plus 1. So that means now here, f of x is equals to x plus 1. So this function is a polynomial function. Or we can even say this is a linear function, because I'm going to get a straight line. So on these kind of function, whenever we have a polynomial function, you always, well, basically here, all the value of x are going to work here. So if all the value of x are going to work, then that means there won't be any discontinuity or any discontinuous point. So in that case, we say that the its function is continuous continuous from negative infinity to positive infinity, right? So basically all the real numbers are going to work. Okay, now there is another one, another definition. A function f is continuous on an interval. So now we are working on interval. So the previous one we're working, we did an example for 1 point, right? Or basically find a point where it is discontinuous. Now, well, it's similar idea, but now we're considering an interval where it is continuous on an interval. Basically, even on this one, okay, even on this one, since we said that it is discontinuous at this point, right? So everything else except this point, it would be continuous, right? So even that was the interval, but yeah, like I said, the idea here is same thing. An interval, if it is continuous every number in the interval. So let's say it's obvious, right? So a function is continuous on interval. So let's say there is an interval m and n. So we can write the interval in this way as well. So this means the interval is from left hand side, from m to n. Or basically, if you see this number line, let's say if there is m here, there is n here. So yeah, it's continuous in interval if it is continuous at every number in the interval. So at every point or every number in this interval, if it is continuous, then we can say a function is also a continuous function. All right. So let's look at one example. Let's say so that a function now, so I'm not going to write whole thing. So let's say so that a function f of x is equals to 1 minus square root of 1 minus x to the power 4 is continuous on the interval okay, again, the interval is from -1 to +1, right? So like I said, the interval we can write this way as well. So now I need to, I need to find that basically a function is a continuous function and this interval. So like I said here, it has to be continuous at every point in this interval, right? So if I draw a picture, so I'm saying that, okay, on left hand side, I have -1, on right hand side, I have +1. So every point here, it should be, every point, yeah, and between these two intervals, it should be continuous. So so let's say this, let's say there is a random point or any point on this interval, let's say that point is A, okay? Or A is in between -1 to +1. We are not including this in point, all right? We're just saying any point in between these two, all right? So now let's write our actual solution for this. I'm just making this picture to explain what exactly the problem was asking, all right? So now let's write the actual solution. So let's say for this interval, for negative, so this is a solution. For -1, or basically if A is in between -1 to +1, let's say that x goes to that point A. We don't know what point is it, but we're just saying that it is a point, some point between that interval, right? And x goes to A on this function. And the reason I'm saying this is, or what I'm trying to do here is, if you see the first definition I said, so if I prove this thing, so I'm starting from left hand side. So if I start from left hand side and if I get right hand side f of A, then I can say that the function is a continuous function, right? So that's exactly what I'm trying to do here. So now limit of x goes to A, and f of x is 1 minus square root of 1 minus x to the power 4, right? I haven't used the limit yet, so like I said, every time you have to write limit. And after this, let's say, okay, x goes to A, means, okay, let's say x goes to A, that means I'm going to get 1 minus square root of x minus A to the power 4. All right, so when you say this, this is also f of A, right? If you say f of A, that means we will get this one as well. So basically here, that means I get from left-hand side to right-hand side like this. So if you get these conditions, then you can say that the function is continuous between this interval. But still, we haven't included this -1 and 1 yet. All we proved here so far is that it's continuous any point on this interval is, or any point between this interval is continuous. Now let's look at this actual endpoint. Right now, let's say at x is equals to -1. So when we're saying, okay, now when we're saying, yeah, this interval, that means, well, there must be some graph, right? Some graph, I don't know, something. Let's just say a graph is something like this, since we have x to the power 4, so maybe the graph would look something like this curve. Right now, at this point, since we are considering this interval, so at this point, the graph is basically coming from right, like this, right? So there should be a positive sign on the top, so which means a graph is coming from right. So that means I have to look, the limit of x goes to -1 from the right of this function, f of x function. So again, from this function, if x goes to 1 from the right, then I would get 1 minus square root of 1 minus x to the power, or 1 to the power 4 is still 1. So 1 minus 1 is 0. So square root of 0 is still a 0. So that means I'll just get just 1, right? Similarly, so that means, again, yeah, this is also similar to f of 1. So here we are considering a variable. We got that variable here. Here we are considering a number, and we got that number. Sorry, this is f of -1. Considering this, and we got that here, right? Similarly, at x is equals to now +1 now from left, right? Because the graph is approaching towards +1 from left hand side. So from left, so again, take limit where x goes to 1 from left of that function. Then it would be again similar thing, 1 minus 1. Then again, this is 0, so I'm going to get 1. And this is also f of 1, right? Because here, since we have x to the power 4, so if even though if x is -1 or +1, we still get this 1, right? Okay, so here we got we found continuous for something that is in between -1 and +1. Also, we said found that it is also continuous on that endpoint -1, and also it is continuous at that the endpoint +1. So that means we showed that, okay, this function is continuous, right? We showed that. So yeah, this is how you need to show your work. If I ask you something like this in the exam, and I might ask something like this in the exam, right? Because I think this is a really good example, and this is a really good problem to ask in the exam. Okay, let me do a few examples. Okay, let's find. Okay, let's find. It's a different color. F of x is equals to x to the power 4 minus 2x to the power 3 plus 7. Okay, now let's find at what interval the function is continuous. So we need to find the interval. That will make this function continuous function. Okay, so now one thing, okay, so whenever a function is a polynomial, then we can directly say that, like I said on the first example I did, or basically here, right? I got this one a linear function, or even we can say that is a polynomial. So in that case, we can directly say that it is continuous everywhere. So it's the same thing. even though now here it is a linear function, which is also a polynomial function, but this is not a linear function though, but still this is a polynomial function. So that means the interval is from -infinity to +infinity. So everything will work. Similarly, let's say if f of x is equals to x squared plus 2x plus 17 over x squared plus 1. So again, we need to find at what interval this function is a continuous function. Okay, so here one thing we can see that this is a rational function. How do we say it is a rational function? When you divide two polynomial, so this thing on the numerator, this is also a polynomial, this thing on the denominator, it is also a polynomial. So when you divide something like this, it is a rational function. And whenever we deal with the rational function, and we are trying to find if that rational function is continuous or not, then we need to look at the denominator, whether we get anything, well, whether we get this function undefined at a certain point or not, right? But when you look at this point, or when you look at this function in the denominator, there is no way I can get 0. Doesn't matter what x you choose, even if you choose -2, -3, because of this square, it will make it positive, right? And there is a plus here. If there was a negative here, then we can do that. We can make a point where it is going to be a discontinuous. When you say x is 1, then it will be 1 minus 1, which will be 0 on the denominator. But when you're saying plus here, again, there is no way I can make it 0. So that means, again, in this case, all the x values are going to work. So again, this will be continuous from -infinity to +infinity. So again, I might ask you this kind of problem as well, explaining that you need to explain, okay, I'm going to ask probably something like this, and you need to explain why we get this. The reason is exactly whatever I explained here. So you need to explain that thing in your own way in the exam. If I ask this thing in the exam, yes, you have to explain that in your own way. All right. So that's it. And if you watch the whole video, probably you notice whether I asked any quiz or not. And like I said, if I assign any quiz, then it is due the next day, right? Because since this is a Tuesday lecture, so if I assign any quiz in this video, then it will be due Wednesday. But if you watch the whole video and if you don't see anything, then you don't have to submit anything. That's the rule. All right. Okay, that's it for this section. Yeah, if you have any questions, feel free to email me anytime, or you can just come to my office hour. All right, come to my office hour through Zoom. All right, thank you. See you later.